So in today's lecture, we'll discuss about the searching. Okay. So we have the different kind of searching. Searching means basically what? Searching means to find an element in the array. So the finding process may be the different way. Okay. So in that case, I'm sharing with you. You can see here that we have a different type of algorithm in the searching. In today's, we only discuss about the searching. In the next class, we discuss about the sorting. So now you can see here we have the total number of 5 sorting techniques. The first one is a linear search, then bind the interpolation, jump search and the exponential search. In today's class we discuss about the linear search. Okay. So now how the linear search works. So in that case you can see here it is very easy. The first thing is we have an array. Okay. Now 25, 10, 35, 40, 15 and 50, something like this. We have an array and we want to find this in this element we want to find. So how we can find? That means you need to compare this element from every element. So now the first step is what? We need to check the 25 with the 40. If it okay, then find the element, otherwise continue. The next step is 10 compare with the 40. Still there is not finding. So now again 35 to 40, continue. Now the next one is 40 to 40. It means we have found the required element, the target element we have found. So in that case we need to stop the process and then we record the index number. And I am also telling you that the index number and position both are different. When in your exam ask what is the index number of this element, so the index number of this element is 3. But when we are talking about the position, so position is not the index number. Position means the n plus 1. So it means what we have, so the index I plus 1. So in that case 3 plus 1, fourth position. We have got the element at fourth position but at third index number. Okay, because our array start from the 0th location. Now you can see here we have a different type of complexity. So in that case, best case, worst case, average case, we have the different type of complexity. Best case is order of 1. How? It means suppose if I want my target element is 25 and I find the 25 on the first position. This is the best case. Average case and worst case in the linear linked list both are same. Why? Because in any case, we have to find the element in entire array. Maybe that element, suppose that element is 40, so we have found it at 40 here. Maybe if the target element is 10, so we found the element at second position. So in that case, the average and worst both are complexity is order of n and order of n. Now come to the algorithm, that how to write the program. So in that case, what we required? The first thing is array. A is an array. Array is this. Okay. Now the n means number of element. Okay. And the key means that element which you want to find. Okay. So in that case, how to work? The for I is equal to 0 to n minus 1. Okay. Because the array starts from the 0 and at the n minus 1th location. Okay. So that's why I am writing here the 0 to n minus 1. And then if the array of I is equal to key is a target element and array of I is each element, we are comparing the key with each element. If we found, so in that case we return the I is the index number. Okay, not a position. We return the I. If not, suppose that element is not exist in the entire array. If I am talking about this, suppose I am talking about the 30 is not in this array. So in that case, you can get the return minus 1. That means you can get the minus 1. Okay. So your process is failed. Okay. So now this is the linear linked list.